Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to arithmetic progression. So far we have discussed the various questions related to the general nth term of an AP. First from the beginning and then from the end. Mostly we discussed the general nth term from the beginning. Most of the questions were around that, and also some from the end, okay, the general nth term. So in this video we are going to discuss another important concept related to arithmetic progression, which is the sum of the number of terms, whatever number of terms, let's call it n, sum of n terms of an arithmetic progression. Okay, this is the topic. Okay, let us say we have an arithmetic progression. Okay, we have the first term a, the second term a plus d, where small d is the common difference, small a is the first term, then the third term a plus 2d, the fourth term a plus 3d, and so far it will go on and on and on. And if we write from the last, let the last term be small l, the second last term, taking it from the last, considering it from the last, it is l minus d, the third last term l minus 2d, the fourth last term l minus 4d, l minus 3d, this is not 4d, by mistake I've written, it's 3d, l minus 3d, and so on. Okay, this is the arithmetic progression. A is the first term, d is the common difference, and L is the last term of the arithmetic progression. Now let us say we want to determine the sum of these terms. Let the total number of terms that are present be n. Okay, total of n terms are present in the AP, the total number of terms present in the AP. So the sum of the n terms, let's call it Sn. Okay, the sum of the n terms of this AP, we will write it as a plus d plus a plus 2d plus a plus 3d, likewise then from the last l minus 3d plus l minus 2d plus l minus d plus l. Okay, so this is the sum of the n terms of the AP. Let's say this is equation 1. Now suppose we write the same sum equation, the sum of n terms equation, but in the reverse order, starting from the last. Okay, we write the same thing but we just reverse it. So we write it as the sum of n terms starting from the last L plus L minus D plus L minus 2D plus L minus 3D plus A plus 3D. Just we are writing in the opposite order, okay, the reverse order. A plus 3D plus A plus 2D plus A plus D plus A. Let's call it equation number 2. So we have the first equation, A plus D. In the starting from the first, we add all the terms that are present in the AP. In the second equation, we write the same sum equation, sum of nth terms, but in the opposite order, in the reverse order, starting from the end. L, L minus D, L minus 2D, L minus 3D up to the first term A. Okay, here from first to last, here from last to first. Now, suppose we add these two equations, okay. Suppose we add these two equations, 1 and 2, okay, we add them here and here. So this becomes 2Sn, Sn plus Sn, 2Sn, first term and last term, sum of these two, it becomes A plus L, okay. Here we have A plus D, here we have L minus D, plus D minus D gets cancelled and we have only A plus L, okay. Similarly, next A plus 2D, L minus 2D, when we add them, plus 2D minus 2D gets cancelled, we have A plus L. Similarly here, A plus 3D, L minus 3D, plus 3D minus 3D gets cancelled, A plus L. And it goes on and on and on. Here also, L minus 3D, A plus 3D, minus 3D, minus 3D, we have L plus A or A plus L, same thing. Then here minus 2D plus 2D, here minus D plus D, so we have here also A plus L here, and the last here we have L and A, which is A plus L. So a total of n times this happens. This dot 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 represents n times A plus L is the total number of A plus L terms that are present here in this sum. It is n times. So because there are n number of terms in each, so here we can write it as, this is n times. Let me write on the top of the dot, n times this addition happens. So we can write it as, that implies 2Sn is equal to n into A plus L, that is the sum of the first term and the last term. Or we can write it as, that implies the sum of n terms Sn is equal to n by 2 into A plus L. Okay, this is the first important formula related to the sum of n terms of an AP. Okay, this is the first formula. Let's write it as this. Okay, the first formula here. Okay, so this is the first formula. Now we know that for a general nth term of the AP, let's say the last term, we have already discussed it in the general nth term of AP equation. The last term of the AP, okay, the last term of the AP which is generally the last nth term, it is expressed as A plus n minus 1 into D, where n is the last term of the AP, which represents the last number, particular term number in the arithmetic progression. So if we replace this L with A plus n minus D here in this equation, then we have the second formula, which is Sn is equal to n by 2 into A plus, let's use a different bracket, A plus n minus 1 into D. Okay, we have replaced L with this equation, A plus n minus 1 D. So this gives us the second formula. Okay, the second formula of the sum of n terms of an AP, which is equal to, here Sn is equal to, okay, n by 2 2A, okay, 2A plus n minus 1 into D. Okay, let's erase this portion, it was lagging a bit. Okay, let me write it in a proper way. Okay, this is 2A plus n minus 1 into D. So this is the second formula, again derived from the first. This is the second important formula of sum of n terms of an AP. Okay, n by 2 into 2A plus n minus 1 into D. Here A is the first term, small d is the common difference, L is the last term, and n is the total number of terms that are present in the arithmetic progression. So these are the two formulas related to finding out the sum of n terms of an AP in an arithmetic progression. Okay, so this is the